also known as Shirtless Guy 666, and also known as Jimmie Rex Wiseman, Jimmie Rex Wiseman Jr., if you want to say that. Okay, so I thought I would talk about music theory today. Not just modes and playing them, and not math, but music theory. And it connects to math, but it's not pure math. Okay, first of all, music is based on vibrations, and a string vibrates or something else vibrates, whatever, and the vibrations are periodic, and they follow a sine wave or a cosine wave or something like that. And so let's say I have a graph here, and this might be time, and this might be amplitude, the amplitude of the wave. Okay, now this is kind of interesting actually, if you can follow this. Let's say I have a wave that makes one cycle in this many, and I call that period. I call that period capital T, the period of the wave. But the frequency of the wave, or F, is 1 over the period. Therefore, if the period goes up, the frequency goes down. If the period goes down, the frequency goes up, because they're inversely related. Okay, now here's the trick, though. When you have a string vibrating at this frequency, it doesn't just vibrate at this frequency. It vibrates at every multiple of that frequency. Every time the frequency gets multiplied by itself, the period also gets divided by the same number that you're multiplying the frequency by. So let's say the frequency goes up, which means the period is going to go down. So I'm going to make it go like this, that wave. And that wave has half the period as the first wave, but twice the frequency. And that frequency is also sounded by the string, and that frequency is twice the frequency of the first wave, which is called the fundamental. And this frequency of being twice is called an octave. So I'll get to that in a minute. But the trick is that if it works for every other multiple of the wave, multiple of the frequency too. Like, let's say you want to multiply the frequency by 3, then you just take the period down to 1/3 of that. So now I would only have like a quicker wave, like this. And then it would go like that. That's even quicker, and that's 3 times the fundamental frequency, and that would be the perfect fifth plus an octave. So there's that. And then 4, fourths, 4 times the frequency, which is 1/4 the period, would then be the double octave, because it would be half of half. So if twice the frequency or half the period is 1 octave, then half the period of that, or twice the frequency of that, which is 4 times the original, would be the double octave, and so forth. So you get the point of this frequency talk. The one first wave is called the fundamental, and the others are called the overtones. Okay. How should I do this? But before I go on, there's also undertones, but they're not physically available in nature. A string doesn't make frequencies multiples, doesn't make fractions of that original frequency, which would make the period go up, which would make the longer period, and that would make half the frequency. If it's twice if the period is double the original period, it would be half the frequency, and that's an undertone because it's lower tone than the original. But that doesn't really exist in nature, because no string makes frequencies that are less than the fundamental. But it's good to think of it as abstractly in the concept of it. So here's the gist of it. If you go the opposite direction, you have the undertones, and that would be the reverse or mirror image, or you could say negative harmony, LOL, of the overtones. And so whatever intervals the overtones make going up, the undertones would make a reverse image going down, negative harmony-wise. So let's start with the scenarios. If you have the original frequency of whatever, call it X, then double the frequency would be 2F, and that would be this frequency, the original frequency would be called as well, would be the unison or the root, the trivial interval. But the double the frequency would make the octave. Triple the frequency would make a fifth plus, let me get that right, fifth plus octave, and so forth. And then fourth times the frequency would be twice the double octave, the octave above the octave. And so it would be the double octave. So there's what you do. With these overtones, you have, I think you understand how they're derived and how they work. Let's just figure out which ones are important and what the intervals are. So the fundamental is the unison. Twice is the octave. So I'm going to start with, let's say, a staff, or let's say I could have, let's make a staff. Why not? I'm schooled in music. Let's say I'm on C. Let's go like this. It's middle C. So the first interval that comes into play would be the octave. And that's the frequency that's twice the fundamental. That would make this note right here. That's the octave, and that's good. And then the three times the frequency would make an octave plus a fifth. But if I bring that down an octave and make it 3 halves, or half of 3 times the original frequency, you would get a perfect fifth, and that would be right here, and that would be the note G. So you have C is the fundamental, and here's C is the octave. Then the G is the first non-C note that comes into play. That's called the perfect fifth. Then 4 times the frequency makes a double octave. We've covered that because the octave is still there. 5 times the original frequency makes a major third. That would be E. So E is the major. I'm going to do it funny. I'm going to write a right side up triangle third, major third. Okay, that's good. Then 6 times the frequency makes another octave. It would make 6 times it. What the frequency would make? Let me think here. 6 would be double the double. It would make double the octave plus the fifth, because that's a third. Double it, you'd get 2 octaves. 2 octaves and a fifth. Let me see. The sixth frequency would give you twice the octave. Twice the perfect fifth. Let me think. C. 6. Yes. Okay, I got it now. It's the octave of the octave above 3, 6. 3 is a perfect fifth. If I multiply it by 2, I get 6, and that would be the octave of. Okay, so that would just, that would just be 2 octaves in a perfect fifth. So we already have the perfect fifth. It just would be 2 octaves plus a perfect fifth. So that perfect fifth is already, again, G. We already have that. Thanks for the, we got there for a second. So basically, then if I do the seventh, 7 times the frequency, I get a note that's not in tune with any of this. It's, someone called it, I think Schubert said it's almost an A. Well, it's between A and B flat. It's out of tune. And since prime numbers generate original tone, 7 is a prime number, we don't use that 7th overtone in our music theory. And then the 8th overtone, 8 times the original frequency, would just be the triple octave. 1 octave would be 2, 2 octaves would be 4, and 3 octaves would be 8. So what I have is, and we already have the octave, which is C. So with the overtones, I have a C, E, and a G, and then an octave above. So I have a C, E, and a G. That's called a C major triad. So what happens is, the C major triad is based on what's called the scenarios. Scenarios. And that's just the first 8 partials, which would be the fundamental plus the first 7 overtones above the fundamental, not including the 7th overtone. I mean, yeah, 7th partial or 6th overtone, which would be between A and B flat. So the scenarios is basically just a major triad based on the first, based on the overtones. And I'm going to write this in like it's going up. And what you have with the major triad is C to E to G. C to E is a major third. So major third. E to G is a minor third. I'll write a little minor third. Okay, that makes C major. Now the question is, what about the undertones? Well, they're just the reverse. It means a mirror image. So that would be C would still be the center. Then you'd have a major third down from C, which would give you A flat. That would be A flat, okay? And then below that would be the next one below that would be the mirror image of the 5th, which would be a 5th below, which would be an F, because that would be a perfect 4th above, or a perfect 5th below. So I have, for the undertones, does not look like a very good C. I have C here. Now, for the undertones, I have F, E, A flat, and C. The interesting thing is, it doesn't really start, technically, it springs from the C, but because of music theory always being reckoned from the bottom up for roots, I'm going to take the F as the root of this chord. And what we have then is an F, A flat, and C. What would that be? Well, F, A, and C is an F major triad, so F, A flat, and C is an F minor triad. So you have, the undertones give you F minor triad, and the overtones give you C major triad. So therefore, when you start with a note, you have the major triad on that note going up, and then you have a minor triad, a perfect 5th below that going up, and both those are implied by the going up. The up major is implied by the overtone series, and the perfect 4th minor triad up would be the undertones. And this is what they call negative harmony as well. The F minor triad is a negative harmony of C major triad, because one is a melodic inversion of the other. And that brings me to another topic. It's called negative harmony. Negative harmony. And the other thing is called musical palindromes. Now, a negative harmony, let's talk about that with actual real music. So let's say I have scales. And Rick Beato talks about this a lot, but he insulted my intelligence once by saying that no one could ever have thought of his theory of on one of his videos, and I'd already thought of it 3 years earlier, and I thought of negative harmony when I was a kid. I just didn't call it that, so I unsubscribed for his arrogance, but he's a good teacher. Okay, let's say I have scales. Let's say I have a clock. Let's do it my funny way. And now 0 can be D, and then 2 can be E, 3 is F, 1, 2, 3. I want to make that a little, wait, let's make it a little more accurate here. Yeah, this like this. Okay. Let's say I have a clock. I think that's to come off, doesn't it? That's 3 here, 3 here, 3 here, 3 here. Let's make D the center. Two half steps above that is E. A half step above that is F. A whole step above that is G. E, F, G, D, E, F, G, D, F, G, A. Let me think I get this right. Yes. Then a whole step above A, G would be A. Whole step above A would be B, and a whole step above, and a half step above B would be C. So I have D, whole step higher E, half step higher F, whole step higher G, whole step higher A, whole step higher B, half step higher C, and whole step higher D. Now D is perfect for this because it divides the octave into symmetry because of the nature of the D being the center note. Because D is a musical palindrome of itself, because if the D going up or clockwise is the same intervals as the D going down or counterclockwise. Let's explain this. If I go up, I get from D, I get whole step, half step, whole step, whole step, whole step, half step, whole step. But if I go the other direction, I get the same thing, just going the other way. From D, whole step down, half step down, whole step down, whole step down, whole step down, half step down, whole step down. So D, the mode for D is Dorian. So D Dorian is a musical palindrome because it's the same going up as down. It's another fancy way of saying melodic inversion, but negative harmony is quicker to say and it sounds more impressive because you sound like you have your vocabulary or something. But here's the last thing I want to cover. But the other modes aren't musical palindromes, but they can be negative harmonies of each other. Whereas D was a negative harmony of itself, but the negative harmony of E Phrygian, because that's the mode on E, would be C Ionian. Why is that? Well, E Phrygian, E Phrygian, and then C Ionian are musical palindromes of each other. Why? Well, E Phrygian going up is half, whole, 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 half, whole, whole. And C Ionian going down is half, whole, 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 half. Wait, let me do it again. C going down is half, whole, 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 half, whole, whole. Since that, so therefore, E Phrygian is the negative harmony of C Ionian and vice versa, because the Phrygian going up is the same intervals as Ionian going down, and also for that matter, Phrygian going down is the same intervals in the same order as intervals for C Ionian going up. So you have C Ionian as a musical palindrome. Is a negative harmony of E Phrygian, and then so on with the other sets of intervals. Sets of modes. F Lydian is a negative harmony of B Locrian. So F Lydian and B Locrian. So that's because F Lydian going up is whole, 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 half, whole, whole, half, and B Locrian going down is whole, 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 half, whole, whole, half. Same, what the and the leading going one way, the F leading going one way is the eloping going the other way. And then the last set of, and this is what I thought of when I was a kid. I was like 20 years old when I thought of this. I just didn't call it negative harmony. The negative harmony of G mixed Lydian is A aeolian. So G mix Lydian and A O Leon are are negative harmonies of each other, because the G mixed Lydian going up is whole, whole, half, whole, half, whole, and the aeolian going down is whole, half, half, whole. So this is a quick introduction to negative harmony, and you know that the major triad is the major triad is the negative harmony of the minor triad. And lastly, I always want to cover the thing Rick Beato said. He said that no one would have thought of this, and he guaranteed it. Well, I had, so I unsubscribed from him. The harmonic minor scale is the negative harmony of the harmonic major scale. This is because the two scales only differ in one note, and that's the third. The harmonic minor has a minor third, which makes the, if let's say I'm in A harmonic minor would have a minor triad because it has a minor third. But the A harmonic major scale would have a major third, so it would be A major for the tonic triad. Well, since the tonic and the other notes are the same, and the other notes make a diminished seventh arpeggio on either the major third, major second, perfect fourth, or minor sixth. But the other three notes make an A major triad, an A minor triad in harmonic minor scale and a major triad in harmonic major scale. So because A major, because A minor and A major are negative harmonies of each other, that means that the harmonic minor scale is the negative harmony of the harmonic major scale. And that's what Rick Beato so proudly said. I guarantee none of you out there thought of this. And I thought of it 3 years before that, and like I've said. So, there's a few other scales that are musical palindromes as well. I'll cover that real quickly. The ones I kind of like. The first one is of the melodic minor, a mode of the melodic minor scale, which is called Aeolian dominant, which is also could be Mixolydian, flat 6. The Aeolian dominant, if you're the D Aeolian dominant mode would have a C sharp in it, and the C the A dominant. I'll put it this way. Which mode would it be? Third, fourth, fifth. The fifth mode of Aeolian dominant would have a C sharp in it. So you would have A. The notes would be A, B, C sharp, D, E, F sharp, G sharp, A. And repeated that again. Aeolian dominant would be A, B, C sharp, D, E, F sharp, G, A. No, G sharp, A. No, not G sharp, A. That's Aeolian dominant, right. So it's A, B, C sharp, D, E, F sharp, G sharp. No, G, A. What am I doing here? Let me see if I got this right. That. Oh, that's right. I got it. A, B, C sharp, D, E, F sharp, G, A. Okay, and that's a musical palindrome itself because up would be whole step, half step, whole step, half step, whole step, whole step, and down would be whole step, half step, whole step, half step, whole step. Okay, and then the mixed leading flat 6 is would be the fifth mode, also the fifth mode of let's say a C melodic minor scale, and the fifth mode of, that would make it a G mixolydian flat 6. That's its own palindrome because a G mixolydian mode flat 6 is up whole, up half, up whole, up half, up whole, and back downward, down whole, yeah, down whole, down half, down whole, down half, down whole, down whole. So in this case, it would be it would be the fifth mode of a C major scale with a flatted third, which would make a C melodic minor scale. So the melodic minor scale can be thought of in two different ways. I'm just throwing this in there. Sorry about the thing. D melodic minor scale can be spelled D, E, F, G, A, B, C sharp, D. Whereas the C melodic minor scale is spelled C, D, E flat, F, G, A, B, C. But these scales are the same scale, only one is spelled with a sharp and a sharp note, which is this in this case C sharp, and one is spelled with a flat note, in this case E flat. But that's because you can get a melodic minor scale from a major scale two different ways. First of all, by flatting the third of the major scale, which would make it give it E flat, or raising the seventh of a Dorian mode, because D, the mode of D in the C major scale is Dorian. So the sharp to seventh, which is C sharp, in melodic minor, you would just take a Dorian mode with a sharp seventh, and that would be a D. If it's a D, you start with D Dorian mode, sharp to seventh, you get D melodic minor. Start with C major scale, flat to third to get C melodic minor. Okay, so I hope I did that good. I think I made everything right, and I hope you enjoy this video. Hope you listen to music theory. It always helps me to learn to teach. By teaching, I also learn, and hope you enjoy this. And please have a great day, and talk to you later. Bye-bye. Jimmie out.